Good morning. Let us study today angular wave function. What are called angular wave function and what are called angular probability functions. Theta phi, the product of theta phi is called angular wave function. On squaring the angular wave function, the angular probability function is obtained. The angular wave functions or the angular probability functions are mathematical equations. Therefore, they can be plotted. Plotting of the angular wave function or angular probability function gives the shapes of the orbitals. Let us see the significant features of these curves, plots, and what are called nodal planes especially. What are called angular wave functions and angular probability functions. We know that the total wave function is obtained by solving the Schrödinger wave equation of hydrogen atom or hydrogen-like atom. We have already studied by solving the Schrödinger wave equation of hydrogen atom, the total wave function psi equal to capital R, capital theta, capital phi is obtained. Where R is the radial wave function, we have already studied what is called radial wave function, radial probability functions, etc. Where theta phi is called angular wave function. The product of theta, capital theta and capital phi is called angular wave function. Or it is also called spherical harmonics. We have already studied in hydrogen atom problem. The angular wave function has no physical meaning or physical significance, whereas the angular probability function has physical meaning and significance. It is obtained by squaring the angular wave function, theta square phi square. The angular probability function, the plotting of angular wave function gives the shapes of the various atomic orbitals. The angular wave function for different orbital is different. Each orbital, for example, has different angular wave function. Each orbital has, S orbital has a different angular wave function because the angular wave functions represent the atomic orbitals. The angular wave function also varies with the directions of the orbitals, orientations of the orbitals. For example, px, py, pz have different angular wave functions. The angular wave functions are nothing but mathematical equations for the s orbital, pz orbital, dz square orbitals are shown in this equation. As seen below, the angular wave functions are independent of the principal quantum number. For example, for 1s orbital, L equal to 0, ML equal to 0, the angular wave function is represented by a mathematical equation. It is independent of theta, 1 by 4 pi square root. Okay, where theta phi, capital theta, capital phi for pz orbital equal to square root of 3 by 4 pi into cos theta. It depends on cos theta, whereas the angular wave function for the dz square orbital is given by this capital theta, capital phi equal to square root of 5 by 16 pi into 3 cos square theta minus 1. Okay, so the angular wave functions for the various orbitals are given here. The mathematical angular wave functions, the angular probability functions are then plotted and are shown in the figures. What is the effect of squaring of the angular wave function is theta phi, whereas the probability functions are obtained by squaring the angular wave function. What is the effect of squaring the angular wave function? Different orbitals change in different ways on squaring. For 1s orbital, on squaring the angular wave function, the plots of angular probability functions do not change For example, 1s orbital is spherically symmetrical. It is everywhere positive. It is everywhere plus, everywhere positive. Okay. And it is spherically symmetrical. The s orbital is spherically symmetrical, obtained from the plot of angular probability function. Similarly, for pz orbital, there are two circles, and this is the dumbbell shape. Pz orbital is represented by dumbbell shaped, and here this is positive and this is negative. That is, here it is not everywhere positive. Okay, and also for pz and d orbitals, the angular probability functions are more elongated along the, for example, for pz orbital, they are more elongated along the z axis. The angular probability functions plots tend to become more elongated on squaring the angular wave functions. Let us see here what are called nodal planes. What are called nodal planes? The angular wave functions, the angular probability functions for 1s orbital, p orbitals, d orbitals are shown here. Okay, and here it is spherically symmetrical, everywhere positive. As I said, it is everywhere positive. This is the mathematical symbol plus. Okay, it is and for 1s orbital there is zero nodal plane. There is probability of finding the electron along x-axis, y-axis and z-axis. Whereas for pz orbital, the probability of finding the electron is along the z-axis only. Along the plane, xy plane, along the xy plane, this is called nodal plane. For pz orbital, there is one nodal plane along the xy plane. For px orbital, the nodal plane is along xyz plane. Okay, what is nodal plane? This is the plane where the probability of finding the electron is zero. The probability of finding the electron is only along the z-axis. Therefore, the probability of finding the electron along xy plane is zero. Therefore, pz orbital, there is one nodal plane. Next, d orbital, for example, dx square minus y square orbital, the lobes are along x-axis and y-axis, and as you see here, there are two nodal planes along this. This is a nodal plane, and there are two nodal planes. Okay, the shape of d orbital, dx square minus y square orbital, is double dumbbell shape, and this is 1s orbital is called GERADE orbital, whereas p orbital is UNGERADE orbital, d orbital is called GERADE orbital. What do you mean by GERADE, UNGERADE orbitals? In German, GERADE, in German, if the orbital is symmetrical with respect to inversion center, for example, plus here and along the center of center, if you move here, plus everywhere positive. Here, if you move from here along the center here, plus, it will be minus. Therefore, p orbital is asymmetrical with respect to center of inversion. So it is UNGERADE orbital. P orbitals are UNGERADE orbital because they do not have center of symmetry or inversion symmetry. Here you start from here and pass through the center plus. Similarly here minus, you will end up with the minus. Therefore center of symmetry is present. In the case of d orbitals, there are center of symmetries. Therefore this is again, d orbitals are called GERADE orbital. These are orbitals with the center of symmetry. These are symmetrical with respect to center of inversion. These are asymmetrical with respect to center of inversion. There are two nodal planes for dx square minus y square orbital. Thank you for watching.